Hello everyone, I'm Xidong. I'm very happy to be here to introduce my new paper, Auto-Train-Once, Controller Network Guided Automatic Network Pruning from Scratch. The motivation is that current techniques for DNA pruning often involve complex multi-step processes that require domain-specific expertise. It makes their widespread adoption challenging. To address this limitation, the only Train-Once and OTO-V2 are proposed to eliminate the need for additional fine-tuning steps by directly training and compressing a general DNA from scratch. However, OTO has poor final performance. It reformulates the objective as a constraint regularization problem. The local minimum may be scattered in diverse locations, but as the augmented regularization in OTO penalizes the mixed L1 and L2 norm of all trainable parameters in ZIGs, it restricts the search space to converge around the origin point. OTO-V2 improves OTO by constructing pruning groups in ZIGs based on salience score, and only penalize the parameters in the pruning groups. However, model variables vary as training, and statically selected pruning groups in the early training stage can lead to convergence issue of local optimum. Drawbacks in the algorithm design prevent them from giving a complete convergence analysis. For instance, OTO assumes the deep model as a strongly convex function, and OTO-V2 assumes a full gradient estimate at each iteration, which does not align with the practical settings of DNA training. Therefore, we propose a generic framework ATO to train and prove DNNs in a complete end-to-end and automatic manner. After model training, we can directly obtain the compressed model without additional fine-tuning steps. We design a network controller to dynamically guide the channel pruning, preventing being trapped in local optimum. Here we introduce the definition of ZIGs, zero environment groups. In the context of layer-wise deep neural network, entire trainable parameters are divided into disjoint groups. These groups are termed zero environment groups when each group G exhibits zero environments, where zero environment implies that setting all parameters in G to be zero leads to the output also being zero. This is our algorithm. We reformulate objective as the group lasso minimization problem. We use the controller network to decide the pruning groups, and we use the standard proximal gradient to project the parameters. Because we also need to train the control network, we make efforts to reduce actual computational overhead due to the use of control network. We only use 5% data to train it. Control network uses bidirectional gated recurrent unit because it is a lightweight sequence model. It is followed by linear layers to reduce the trainable costs. We divide ZIGs into multiple disjoint blocks, and the sum of blocks is the ZIGs. The block is one layer in ResNet models or one inverted residual block in mobile network 2. We stop the training of control network in the half of total step to reduce the training overhead. So in the CVPR10, CVPR100, and ImageNet dataset, we can see our method has perfect performance. Especially, ATO outperforms OTO and OTO-V2 with different pruning rates.